Associate Director here. Good morning again. My name is Sampath Kannan. I'm the Associate Director at the Simons Institute, and I wanted to welcome you on behalf of the Institute and say a few words about it.
Louder.
Still not clear. Okay. Founded in 2012 with a generous grant from the Simons Foundation, which continues to this day, the Simons Institute is a unique institution in computer science. It's the only place in all of computer science that brings together top researchers in a specific area of research, and mostly in theoretical computer science, to think over a semester on important and hard problems. But theoretical computer science is not an isolated field. It has a window on many other fields, economics, physics, and even the social sciences. We look at all of these things through a theoretical computer science lens. But most importantly, for this group, we have a lot of programs in mathematics as well. For example, in the fall, we have a program on complexity and linear algebra. Next fall, we have a program on spectra of objects beyond graphs, hypergraphs and manifolds and things like that. So these could be of interest to different groups of mathematicians. So we really see strong connections between theoretical computer science and many areas of mathematics, and growing connections between them as well. Now, turning to this event, we are honored to celebrate the life and work of Professor Stephen Smale. He's done enormous number of contributions, which we will hear a sampling of over the week, over the next 2 days, including some contributions to theoretical computer science as well, in terms of the complexity of real computation, which he did some work on with Lenore and others as well. So as theoretical computer scientists, we're excited just from his contributions to this field, as well as his overall contribution. We don't often do these kinds of events. We are mostly set up to do programs that last a semester, but we thought that Professor Smale's career was distinguished enough to make an exception, and we are honored to have this event here. Thank you. And I'll do.
Thank you. Good morning. Thank you very much all to participate in this event, Smale at 95, honoring Professor Steve Smale. I would like to say a few words. I'm a former PhD student of Steve, chairman of UniDT, executive director of Smale Institute. I would like to thank Simons Institute and Dean's Office of College and Letter of Science, many friends and students and also relatives of Steve for organizing this event. So thank you very much, and I think we have wonderful 2 days here at UC Berkeley. And first, I would like to welcome Steve Kahn, Dean of College of Letter and Science, Division of Mathematics, Physical Science, and to deliver his remark. Let's welcome.
So thanks, Michael. And yeah, it's on. Okay, great. Yeah, so good morning to everyone, and welcome to Smale at 95, celebration of Steve Smale's remarkable career in mathematics and his particularly honored place here at UC Berkeley. It's wonderful to see so many friends, colleagues, students, relatives whose lives have been touched by Steve. He truly is a towering figure in mathematics and a real treasure here at UC Berkeley. Steve's contributions to mathematics are really quite astonishing in their breadth and their depth. For differential topology, he turned the sphere inside out. For dynamical systems, where he discovered the iconic horseshoe map on the beaches of Rio. And Steve has reshaped the landscape of modern mathematics generally. His proof of the Poincare conjecture in greater than 4 dimensions earned him the Fields Medal in 1966, as I think you're all aware. But he didn't stop there. He continued to push the boundaries of mathematics into areas of economics, complexity theory, learning theory, and the mathematics of biological and life sciences. Of course, he's won a number of awards over the years. Aside from the Fields Medal, he won the National Medal of Science in 1996 and the Wolf Prize in 2007. And for a mathematician, that's about as high as you can go, unfortunately. Today at 95, he's still wrestling with the Kuramoto model, seeking to understand how synchronization emerges in nature. Steve came to Berkeley in 1964. Actually, he was here a little bit before that, then went off to Columbia for a year and returned in 64. And he's been here for over 6 decades. He's inspired generations of students and colleagues with his fearless creativity into all sorts of new branches of mathematics. Due to Michael, this legacy continues with the Smale Institute for Mathematics and Computation in Shanghai, China. And Steve serves as the chairman emeritus of that institute. His genius isn't confined to theorems and proofs. I think, as many of you know, he's a world-renowned mineral collector. And I'm told you'll see some evidence of his mineral collection tonight at his house for the dinner. Today we celebrate Steve Smale's 95 years. We're really celebrating the incredible person behind the brilliant mind. His unrelenting curiosity and enduring spirit of discovery continue to light our way, showing that true greatness combines an extraordinary mind with an equally big heart. Steve, thank you for all you've given to UC Berkeley, to mathematics, and of course to the entire world. Happy 95th birthday, and may this year shine as bright as your favorite crystals and bring you as much joy as you brought to the world of science. Thanks very much. Okay, let me now introduce Martin Olsson, who's the chair of our math department.
Good morning, everyone. It's such a great honor for me to have this opportunity to say a few words on behalf of the department here at Berkeley for Steve Smale on this occasion. Steve's career covers an incredible amount of ground: topology, dynamics, numerical analysis, as well as more applied areas such as mathematical economics and learning theory. It is truly inspiring to see someone achieve such extraordinary results in one area and then have the courage and skill to take on the most important problems in very different parts of mathematics. At this conference, we will hear about many of Steve's achievements. Let me just mention 3 that stand out to me. You may as well have your own 3. There's plenty. First, of course, is Steve's Fields Medal winning work on the generalized Poincare conjecture and the H-cobordism theorem. His result can be stated quite easily. A closed differentiable manifold homotopic to the n-sphere for n at least 5 is homeomorphic to the n-sphere. This result is part of one of the most remarkable stories in the mathematics of the 20th century, with contributions by many mathematicians, culminating with Perelman's work in dimension 3, which, this is one of the great stories of 20th century mathematics. A second area where Smale has made groundbreaking contributions is in the theory of dynamical systems. As Dean Kahn mentioned, a famous contribution of his in this area is the introduction of the horseshoe map, which gives a chaotic system from a rather simple geometrically defined map. And as I was preparing these remarks, I found quite a lot of very nice illustrations online. So now you can really visualize the complexity of these theorems, which is really interesting. So if you haven't done that, I encourage you to take a look. The other bit of research that stands out to me is Smale's more recent work on learning theory with Cocker and Zhu. This is related to Steve's work on dynamical systems. Developing the mathematical foundations for learning is, of course, an extraordinarily important problem in its own right. But I also note that in the current world of emerging AI, all the more timely and significant. There's so much more to say, but I will leave that to the exciting lineup of speakers. Let me also add, however, that Steve's influence extends beyond mathematics. In particular, thinking about universities and how mathematicians produce their best work, I'm reminded of how important it is for an institution to create an environment where mathematicians feel free to take risks and explore new directions, and more broadly, cultivate a rich and dynamic intellectual environment. On behalf of the math department, I would like to join Dean Kahn in thanking Steve for his many contributions to mathematics and UC Berkeley. Happy birthday.
Okay. Thank you very much for wonderful remarks from Steve and Martin. So let's just begin with our workshop, and I would like to welcome Lenore Bloom to introduce first speakers of first session. By the way, there's